Okay, sorry. Now, you guys are so used to measuring angles in degrees, but there's another way to measure angles. It's called radians. So, here's what I want. On your scratch paper, will you do this? Draw your XY coordinate system, okay, on there. Oh, somebody said, how big should I make this? You're going to make a circle, how about that? Like the top half of your paper. Don't make it microscopic, okay? There you go. Make a circle. On the circle, from the center of the circle all the way to the edge, right here. At 0 degrees, just put this letter R for what?
Radius.
That's the radius. Okay.
Can I speak to you when you get finished with that?
I'll be done in half an hour. All right. So come back. But anyways, that's the radius, right? Okay, now, here's the deal. You are going to measure angles, and you've done this forever. But like if I said right now, can you kind of guess that angle right there? Just guess.
45.
45? Okay. 50?
Yeah, 60, 30.
I would bet it's between 45 and 60. Somewhere there. But you guys all said pretty much degrees. So you guys get this degree thing. And degrees are like this. 1 degree, 2, 3, 4, 5, 6. So how many of these does it take to get it all the way around? 360. The circle is broken into 360 equal parts. Each one's a degree. Okay, now we're going to do radians. From here to here in radians, the answer is not 45 or 50 degrees. It's 1. It's just 1. From here to here. The question is, what's a radian? Well, radian is this. Here's your radius from there to there. That's your radius. If you could somehow pick up the radius off the screen and then pretend it's a piece of string and wrap it around the circle to here. So this is the radius just wrapped around the circle. You end up right on that spot. How far have you gone when it comes to radius? How many radii have you wrapped around the circle right there? Just 1. So that's why we say this central angle is 1. 1 what? Radius. So 2 radians would be this far. Take the radius, wrap it around once, that's 1 radian. Twice, that'd be another radian, which makes what? 2 radians. A radian is a radius wrapped around your circle. So you're up to 2. So from here to here is how far in radians? 2. Where 3 would be somewhere around here, another radius wrapped around. Okay. So this angle would be what? 3. Okay, let's go like that. That would be 3 radians. Okay, and it goes around and around. 4 goes about here. 5 goes about here. 6 about here. Okay? You can just put those down. Just kind of trust me for now, that that's where they land. Okay, here's the deal. When you get halfway around the circle to here, how many radii have I wrapped around the circle right there? 3 what? Okay. It could be 3.5, it could be 3.4, 3.3. Here's what it is. I mean, I didn't draw this perfectly to scale. This is what it is. It's 3.14. But what is 3.14? Pi. So you know what we say when it comes to radians? We say, how far have I gone? How far is this? Pi radians. We don't say 3.14, even though that's what it is. We say this is just what? Pi radians. Now, try to understand when I write pi, I'm writing a number. That's a number. What number? Yeah. Now, tell me where I'm at when it comes to degrees right now. Pi radians is exactly the same as how many degrees? 180 degrees. So these two numbers are the same. One is a measurement of your angle in degrees. One is a measurement in radians. Okay? Now, I can kind of go a little faster now. What do you think would happen if I wrap that radius around and around? I'm up to 5, I'm up to 6. When I get here, a complete circle, how many radians have I traveled?
2 pi.
Okay. If I said number, though, 3.14, double it, you'd be where? 2.8, good. Which you said is really just 1 pi plus another 1 pi is what? There you go. We don't say this, a complete circle is 6.28 radians. We say 2 pi. That's what we say. And 2 pi is equivalent to how many degrees? How much? 360. Good. Okay. So you should know 3 things right now. Thing number 1, you should know that 1 radian, just 1 radian, is 1 radius wrapped around your circle. Continue, continue, continue until you get to here. Okay, you should know this. Half a circle, we say, is how many radians? Don't say this number. It's pi radians. Where a full circle is 2 pi radians. Okay? Does that make sense?
So it's 2 pi r squared. 2 pi, what is
2 pi r. It's pi r squared is what you're saying, I think, for area.
Well, this is why is it like, is that
Well,
why it's
you know
2
what you're
pi?
going into? If you're getting in, we're going to do something with circumference probably on Monday, so just hang on to that thought. Okay?
Jeez,
So you're getting ahead of me, but yeah, you're kind of on the right track. Now, here's what I need you to do. Redo that whole circle, except just put a couple things down. So redo the circle, maybe on the bottom half of your paper, and then do this. Show me where is pi radians and where is 2 pi. You need to do another circle. Don't use that old circle. Now make a new one. Okay, you ready? Where is pi? Okay, yeah, you can say 180 in degrees, but you can say half a circle over here is pi, where 2 pi would be another half a circle, so that'd be right here. So this is where pi radians fall and 2 pi radians fall. Okay, now, that shouldn't have been hard because I just did it. Now do this one. Where is... Don't say a word. Don't say anything. Just put it somewhere in your circle. See if you get it right. Where's pi over 2 on your circle? Gavin, where'd you put it?
I have no idea.
Yeah, you do. You pointed and then you said you had no idea. Come on. You were right, Gavin. You were right. I know where you pointed.
Yeah.
Tell me.
Up in the first quadrant kind of thing.
Like over here?
Yeah,
Somewhere like here?
like there.
Right there?
A little over that way.
Okay, John?
Would it be just at the very top?
Here?
Yeah, because it's halfway.
Okay, guys, you see this pi? This is half a circle. You know what this says to me? Half a circle divided by what? 2. So if you take half your circle and cut it in half, you're only there, aren't you? Now, do you know what degree that is, by the way?
90.
That is 90. Okay? Here's a neat way to think about this. If pi is really just 180, then really doesn't this say 180 degrees divided by what? 2, which is 90, which is right here. So that's one way you can think about it, okay? Yeah, John?
Why is a circle 360 degrees?
Because it wants.
You know, John, I don't know the history on how they came up with the degrees and all that. Why is that 90? I don't know. But I mean, like, once I know that's 90, I can do 90, 90, 90. But I don't know why, you know, why did that make 90? Why didn't it make 100? You know what I'm saying?
Yeah.
I don't know. Good question.
Those Romans and Greeks, they all do this.
Okay, wait. Try this. Try that. Try that. Put it somewhere. Harry, where'd you put it?
On the circle.
Where? Come on, guys. If you don't have an answer, just say pass.
90,
45
halfway
degrees.
between 90.
Halfway between 90.
45.
Oh, okay, he says it's 45 degrees, so he's telling me to put it about here. Well, he's already kind of converted it, it sounds like in his head. Remember, pi is half a circle. Half a circle is just 180. Is 180 divided by 445? Yeah, he got it. That's it. Now, another way to think about it is, take your half circle, cut it into 4 equal parts. Well, 4 equal parts would be here, 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 right? So this is just 1/4. He's right, it's perfect. So where's this gonna be then? Put it somewhere on your side. Okay, Will, where'd you put it?
In between 180 and 90.
So he goes in between 180 and 90, he says it's right here. Yes?
Yeah.
I disagree.
You disagree?
Yes.
Okay, here's the deal. You see this pi? Pi's half a circle. All you're gonna do is go how far around? 3/4 of the half. I already broke it up into fourths. 1/4, 2/4, 3/4, 4/4. Will, you have it right. It's good.
I agree.
It is good. You guys, look what it is. It's divided into 4 parts. 1, 2, 3, 4. Well, how many do you have? 3/4 of the pi. The pi only goes this far. It doesn't go all the way around. Okay? Oh, by the way, if you can count by 45s, what's this? In degrees.
135.
135. Okay? All right. Next, where's this? Where's pi over 6? Kind of close. John?
It's a little bit before the 45-degree angle because it's 30 degrees.
He says because it's 30 degrees. And how do you know it's 30? Because pi is just what?
180.
180 divided by 6. Yeah, you are right, John. It is 30. So it's before the 45. This is probably what? Pi over 6. I'm just trying to help you understand where these things fall. Last one is this one. Where is that? About pi over 3. Just don't say it. Think. Sorry, I forgot to write this. Okay. Taylor, where is it?
In between 90 and 45.
Okay, in between. Dead in between?
6.
It's actually a little closer to the 45. What is this?
6.
Yeah, it's really 60, isn't it? So it's right here. Pi over 3 is pi over 3 is roughly 60 degrees. There it is. Okay. Now, today I was just trying to get you to understand what a radian is, and since radians, it's just a number, and it's how many radii wrap around the circle. Half a circle is 3.14, which is pi. Then I was asking you, what's pi over 2? 90. What's pi over 6? 30. Pi over 4? 45. Pi over 3? 60. We're going to get really good at this next week. We will. I promise. But this was you trying to get used to this stuff. Okay. Now, you've got to convert back and forth. Now, since we're so new at this, there's a way to do it. Here it is. I'm not going to show you radians and degrees. I'm going to show you something even easier. If I said turn 6 feet into inches, how many? Or what would you do? I'm sorry. 6 times 12. I know what you're doing, but 6 feet times 12 is 72 feet. Because you never told me 12 what?
12 inches.
Yeah, but here's the deal.
Over
Feet.
1 foot.
Over one, yeah, it's a conversion factor. This is called unit analysis. If you want feet to go away, put feet on the bottom and inches on the top. Here the feet will cancel with the feet because this is over 1. Now it becomes 72 what? Inches. Now you're right. You need a conversion factor to go back and forth between units. Your conversion factor today will be when it comes to radians and degrees. What do you think? 12 inches equals 1 foot. What?
Does it involve pi?
It does.
So like 1 pi equals 180 degrees.
There you go.
Whoa, John, we gotta go.
Or, okay, who's making the noise? Don't do that. Okay, pi over 180, or 180 over what? Pi. Okay, you will use one of these, and whatever you guys want, if you're looking for, I want radians, use this one. If I want radians, we're going with this. If I want degrees, we go with what? That one. So whatever you guys want, if you want degrees, make sure degrees are on top. If you want radians, make sure radians are on top. Okay? Now, everything I've talked about is in your notes. We can pretty much just start your notes. Okay? I see some of you are writing this out. It's all in your notes, I promise. That part is in your notes. Okay? All right. Here we go. This first part, I don't even have to read it to you because I went over all this radian stuff. Okay? Then you might want to circle a couple things. If you're going to convert degrees to radians, make sure you have radians on top and degrees on the bottom. If you're going to convert radians to degrees, make sure you have degrees on top. Again, whatever you want, make sure it's on top. Whatever you don't want, make sure it's on the bottom. Okay, so how would you do this? What would you multiply by if you're trying to change 127 degrees into radians? Which one would you multiply by, this one or this one? Yeah, if you want radians, you make sure you put radians on top. The second one, radians, let's change it over to degrees. What do you want? What do you want to multiply by?
Second one.
Second one, you want degrees on top. Okay. And that's what you're going to do. You're converting units. You just want one unit to go away and one unit to appear. First problem, negative 210 degrees. Let's convert it into what?
Radians.
Radians. How do they want their answer? In terms of pi. Okay. All right. To get it in terms of pi, you'll multiply by what conversion? Pi radians over what? 180 degrees.
So then what would you put under the negative?
Yeah, that's just a number, so we'll just put it over 1. So now, do you agree that the degree symbol cancels out? Okay. You're in radians right now. You just have to keep working it out. Okay. Negative 210 times pi over 1 times 180. That's your answer, but it's not reduced at all. So we'll reduce it now. What goes into 180 and 210? 10 does. 21 and 18. What goes into 21 and 18? 3. Answer? Negative 7 pi over 6, right? So, negative 210 degrees is equivalent to negative 76 pi radians. Okay? You don't have to write the word radians, because if you don't have degrees, like a degree symbol, I know your answer is radian. If you're in degrees, you got to put the degree symbol. There's one more thing. It says, and give me the decimal rounded to the nearest 100. So here's the deal. I want to know how many radiuses, radii, I wrapped around the circle. What is that number? Okay, type it in. You got to type it in. What's
Do you
negative?
use the pi symbol or would you point 314?
No, never use 3.14 because it's not really the answer.
Okay.
Take negative 7 times pi in your calculator, divide the whole thing by 6.
3.7.
3.6 what?
6, 7.
Okay. So you know, this actually tells me, I took my radius, I wrapped it around my circle 3.67 times around my circle. I went over the pi mark a little bit, a little over half a circle. Good? Okay, so I did this in terms of pi, then I did this to the nearest 100. Okay? Next is for you. Go for it. See if you can get it. 260. Degrees cancel out, right? 260 over 1. 260 pi. Over 180. That is your answer. It's just not reduced. So when you reduce it, you got what?
13 times 9.
Yeah, 13 ninths. Okay. 13 ninths pi. There it is. In terms of pi, how much? 13 ninths. That's over 1, by the way. Over 1 pi, so you know it's gone over half a circle. How far? Give it to me in decimal version.
4.54.
454. Okay. 4.54. Which to me, in my mind, just means I wrap that radius 4 point, almost 270. It's pretty far. Okay. Good. That was converting to what?
Radians.
Now let's convert to degrees. Okay. 2.65 radians converted to degrees. You'd multiply by, if you want degrees, what are you going to multiply by? Yeah, get the degrees on top now. Let's get the radians on the bottom to knock out radians, right? We need radians to go away. That's how it works right there. 2.65, that's just over what? 1. So really, this is just big time calculator. 2.65 times 180 divided by pi. Oh, and it does say, sorry, I forgot to read this to you. Round your answer to the nearest what?
Degree.
Yeah. 17 degrees, 18 degrees, what? 152. Good?
If you want to,
Okay.
you could just do the 2.65 times 180 up before you put it to like look like that. Like you can get rid of the radian and then 2.65 times 180 and then write it as.
Yeah, I mean, you could, I could do this times this, get an answer, divide by pi,
Yeah.
right? Yeah, that's it. That's what you're doing.
Well, yeah.
Okay. All right, next. This one is not written as a decimal. It's written in terms of pi. This one's just a slightly different. Ready? 5 pi over 6 negative. Get rid of radians. Put the radians where? Bottom. Degrees on top. Do you notice anything canceling right away?
Pi.
Yeah, it's just a number. It's like 3.14 over 3.14. They would just cancel out. Anything else cancel? Before I multiply?
6
Yeah.
6 goes into 6 once. 6 goes in here what?
30.
30 degrees now. Okay. Now it's really easy, isn't it? Negative 5 times negative 5 times positive 30 is?
Negative 1.
Negative. You did not need your calculator on that one. That one you could have just use your old noggin, and it would have came up, right? All right. So this is you trying to convert back and forth. Okay, I want to convert quick. I just use my conversion factors. It helps. Now, when you turn the page, you will do exactly what you're going to do tomorrow on the quiz. This is the good part of the lesson today. This is the quiz tomorrow. But tomorrow's quiz, I will say, find cosine of theta and sine of theta, but I'm going to give you what on the quiz tomorrow? Not radians, I'm giving you what? What? Well, degrees. I'm going to give you degrees tomorrow. I'm not giving you radians. So now we're going to do it with radians. This is why I say don't do this lesson until after the quiz. But where is 5 pi over 6? How'd you know that?
That's the power before.
We just did it on the previous page. We just did it. But it was negative, wasn't it?
It was negative.
It was
alright.
negative. So I'm not going to show you the conversion, but it is 150. If you were going to do this on a quiz or a test, you probably would have multiplied by 180 over pi. You would have done that and got to 150. So here we go. Your job is to get cosine and sine of 5 pi over 6. And you know 5 pi over 6 is 100 what? 50. Right here. Right there. Okay. So there's 150, I should say. Or 6 pi. Where's the triangle? Don't see it. But you'll get it by going from terminal to x-axis back to the origin. Terminal, x-axis, origin. Theta hides here all the time, between the x-axis and the terminal side. Just tell me. You have to know this angle, guys. You have to. What is that?
30.
That is a 30. See, now that you know it's a 30, you know this is 60. You know this is right. So now you know your legs, where to put them. Opposite of a 30 is, we used 1, didn't we? Opposite of 60. Square root of 3. Hypotenuse. 2. Now, what did I say about your legs? Some of them can be positive, some of them can be negative. Which one's negative? Square root of 3 is negative. This is why students get it wrong, because they forget they're negative. And the hypotenuse, the radius of your circle, is always positive. Did you hear that? I've said it before, but maybe you didn't hear me. The radius of your circle, the hypotenuse, is always positive. Okay. Now, let's just do the problem. What's cosine of 5/6 pi? Well, cosine is what over what? Adjacent over hypotenuse. Which one's the adjacent side? Negative square root of 3 over the hypotenuse. 2. There it is. We got it. Do sine. Sine of what? 5 pi over 6, which we already drew. It's 150. What is it? Opposite over hypotenuse. 1, 2. 1 and 2. 1/2. And believe me, I'm doing tomorrow's quiz with you right now. Tomorrow, I won't say this radian. I'll just say 150. You'll go to 150. You'll draw the triangle. And hopefully you give me this.
Okay.
You guys, where's that? Where does that fall?
90.
That is 90. Good job. Now, where does 90 fall? Right on. This is the one you use the unit circle for, right? Okay, this is the one where I said, go ahead, use the unit circle. And the unit circle, we said the radius is always what? The radius is always 1, which means this is 1, 0. This one is 0, 1. And this is the one you are looking at, by the way, because this is 90 degrees. If you don't remember that that's 90, here's how you do it again. Pi over 2 times 180 over pi. What happens to the pi? Cross out. 180 over 2, it is 90. Some of you did remember that and some forgot, so that's how you get it. Okay? Now, we talked about this a couple days ago. When it's the unit circle, cosine of your angle, pi over 2, is always what? X. Does anybody need me to show you why?
No.
No? Okay. All right. You said X. So which one's X?
0.
Yep. Cosine of pi over 2 is 0. Where sine of pi over 2 will be what letter?
One.
The y value. Well, which one's y? 1. There you go. And see, it really depends on where you fall in the circle. If you fall here, you're working with 0 and 1. What if you would have fell here? -1, 0. What if you fall here? 0, -1. And you guys, the reason 1 keeps showing up is because the radius is what? 1. It's always 1. That's why the 1 shows up. Okay? All right. Now, out of this one and this one right here, I want to do one of them, and the one I want to do is the one that brings out a 45, 45. Which one is that? Which one do you think is the 45, 45?
D.
Why D?
That was a guess.
That was a guess. That's a good guess.
Because it's divided by 4.
Yes. And if you take pi, if you cut pi into 4 equal parts, it's 45, 45, 45, 45. It is this one. So this is the one I want to do with you. So would you start that one? 7 pi over 4. You might want to figure out what you're looking at in degrees. What is 7 pi over 4? Don't say it. Just do it. Nice thing is pi just cancels out. How about any numbers canceling? What?
180.
180 with the 4. 4 goes into 4 once, 4 goes in here.
45 times.
45 times, gotcha. Times 7 though.
315.
Okay guys, look. We're looking at a 315. 7 pi over 4 is 315 degrees, which leads you to believe you'd be somewhere right around there. Okay? There's your angle in standard form, 315. Where's the triangle? Terminal side, x-axis, origin. Terminal, x-axis, origin. Theta is right there. Big question. What's that?
45.
Yep, you're 45 short of a circle, guys. That's a 45, 45, 90, which means my legs are 1,
1.
-1, square root of 2. Gotcha. That's it. You get that far, I bet you 95% of you get this right. Okay, what is cosine of 7/4 pi? What is sine of 7/4 pi? Let's do cosine first. There's theta. Yeah, but okay. Can you give me the ratio right away?
1
Adjacent.
1 over square root of 2.
Yeah, that's it. 1 over square root of 2. Ah. So there it is. But Taylor already did this in his head. He's already rationalized it to get what? Square root of 2 over 2. Yeah. Sine? Almost the same thing. Opposite over hypotenuse. Just about the same, except what? Yeah, it's this. The nice thing about listen to me. The nice thing about 45, 45s, the answers are pretty much always what? Yeah. And it's usually those answers. Not usually, it's always those answers. The only thing that's going to change on you is the sign. Sometimes they're positive, sometimes they're negative. Pay attention to the legs, okay? If you want, I'm not going to do C. I'm not doing it. But if you want to do C, there, it converts to this angle, and then sine, cosine and sine are right here. I don't want to take up your time now. So if you want to do C on your own, there it is. That's up to you. Okay? Don't start this lesson until right after the quiz. Unless you just, I know what I'm doing on the yellow worksheet. I know what I'm doing on special triangles. Then you can maybe start it. But I don't want you to get any confused before this quiz. Here's the deal. Not many people, showed up last night. Answers for everything but number 26. That's the sailboat one. Is here. Okay, so if you want to check your answers, or just you can take pictures before you leave, there they are. But we haven't done this yet, have we? Have we talked about the sailboat one, number 26?
Yeah.
No? Not yet, hang on. Somebody out there, who did 26? Oh, we got 5 hands up, good. Maddie, what's the answer? Who was you did?
2,741 feet from shore.
Nice.
I got that.
You got 2,000 what?
741
And this is you on the sailboat, right?
Yeah.
Top of the bluff, what degree was this? 16? Is that right?
Yep.
Yeah.
Okay. What else did you know?
And then the bluff was 786 feet.
786 feet. Okay. So really, if that's the look of 26, which trig function did you use? Opposite.
Used
Adjacent.
tangent.
What?
Used tangent so much.
I'm sorry.
This one's used tangent so much.
Yeah, I know. It's well, sometimes you do. You're right. Tangent of what? Equals
786
over x. Right?
Yes.
Wait. You can focus on it. You're good. Have a good night. See you. Anyways, cross multiply. This is kind of the tougher one if you ask me, because this is the one where you don't get the answer right away. 786 equals x times what? Yep. How do you get x?
Divide 10 to 16.
Yeah, divide 786 by tangent of 16 degrees. What is this again? Steph?
It's 2,741 feet.
Point 1.
0.1. Good? All right. That wasn't on my answer key for some reason, so just in case, that's all it was. Anybody done? Totally done with that? Okay, do you have the answers? If you don't, you should come check. The rest of you, just finish it. And stop in after school if you're just not feeling right. Okay. Oh, last thing. You still got 10 minutes, but last thing. Earlier in this week, you did a lesson, 13.2, day 2. 13.2, day 2. It was 7 through 25. 7 through 25. I think we did it on, I want to say Monday or Tuesday. Then you came in the next day and I said, I don't want it. Well, now I do. Can you dig around and, yeah, that's it. It was a very easy assignment. It was sketch.
Oh, the one we had last time.
It was so easy. I got done the day it was supposed to be due.
I think you got it done. I had it in. That's what I gave to you.
Oh, I don't know.
Do you have that though? The assignment I gave to you.
Maybe. I don't know.
I know you
Okay.
Yeah,
I'll
I
see.
have it into that.
Okay, you did.
Dabbling the
He
runway.
did take it though, and then I told him.
13.2, day 2.
As far as we gave you a swag. Yeah, when we
You start working with you put in here.
anyone here want basketball?
Yeah, I can do that.
Jabari Carter towards ACL again. Jabari Carter goes for Bucks.
Good? Hey guys, open your book now. Oh, I said that wrong. Open your yellow packet now and get going. If you have questions, give me to your desk. Okay, can I get everybody over here? This is 13.2 now. There you go. Yeah. Back room?
Yeah.
13.2.
Already got it.
Okay. I will need it. Oh, no, you have to be studying. I answered right. You guys, this special triangle worksheet, this was part of the review. It's the yellow packet and this. Those answers are up there too, so you should go up there. I think I got everybody.
We're talking about this.
I was talking about 7 through